Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
I think the last week we had a discussion about uh, binomial distribution, no? Am I correct? Who can remember the last topic? What is the last topic we discussed? Who can remember? Hello? Hello?
Yes, sir.
Yes, what is the topic that we discussed in the last week? Can you remember?
In the continuous distribution, the normal distribution we have done up to the finding the normal probability, sir.
Yes, yes, okay. That when we learn how to read the normal distribution table, no?
Yes, sir.
Okay, then in the last session we had a discussion about continuous distribution. Under that we learn normal distribution, where we learn how to calculate probability related to continuous random variable. I think we discuss these things. We have to start from here, I think. I think up to this point we discuss, no? Am I correct?
Yes, sir.
Yes. Okay. Then we have a concept called empirical rule. It is applicable for normal distribution. According to the empirical rule, yes, according to the empirical rule, if the variable x is normally distributed, there are 68.26 observations are within one standard deviation from the mean. The empirical rule says that if the distribution is normally distributed, there are 68.26 observations are within one standard deviation from the mean. Is it clear? Now let's say as example, we can assume mean value. Let's say mean is 55. Let's say average age, it is 55. Then let's assume standard deviation is 10. Standard deviation is 10. Let's say you have collect data from your sample size is 200. Your sample size is 200. You have collect data from 200. Then mean is 55. Standard deviation is 10. We assume the variable x is normally distributed. Then according to empirical rule, there are 68.26 observations are within one standard deviation from the mean. If the mean is 55, what would be the value here? Mean plus one standard deviation. That means mean is 55, one standard deviation 10. Then here mean minus one standard deviation. Then the two values are 45 and 45 and 65. That means out of 200, 68.26 person or individual age is between these two values. If the distribution is normal with mean 55 and mean standard deviation 10. That means nearly 68 into 2 mean, that mean out of 200, 68 mean, 68% mean. Hundred and 36 out of 200 between in this age range. Is it clear? Did you got the point?
Yes, sir.
Okay, then in similar to that, it says that within two standard deviation, there are 95% observation. And also within three standard deviation, there are 99.7 observation. Then within two standard deviation, here, what is the value here? If the mean is 55 and if the standard deviation is 10, what are these values? Can you send values into chat box? What are these two values? 55 minus 2 standard deviation. What is the value here? Yes, any answer? Mean is 55. Then what is the value here? Yes, 35. Yes. Then here 75. Then empirical rule says that 95% observations are within this range. Okay. If the distribution is normally distributed. Then as well as within three standard deviation, there are 99.7 observations. Okay, within three standard deviation. Then what is the value here then? Then this should be 55 minus 30, that means it should be 25. Here it should be 85. If the distribution is normally distributed, nearly 100% observations are within three standard deviation from the mean. That's why we consider outlier above Z value is 3. If the Z value is 3, we consider this as a outlier. Okay. Then this you can check with the table also. Okay, you can check with the table also. Let's say now let's say mean is 55. Now I'm going to give one exercise to you. Mean is 55. Then the standard deviation is 10. Okay. Then calculate the probability between this area. That means let's say this is 45, this is 65. What is the probability in this range? That means now you have to find P 45 greater than X and less than 65. Please try to find it. What is the probability in this area? Yes. Can you do it? Hello. Can you do it from the table? Yes. Yes, one has sent the answer. Then if you calculate here, what is the Z value related to this? Just what is the Z value? Z is equal X minus Z is minus 1. Here. Then for this point, Z is plus 1. Then you have to read the table for minus 1 and plus 1. Then you can see the answer. It is 0.6826. I think I have shared with you the Z table. Then please check whether you can get the same answer, or if you want to explain, please let me know, then I can explain how to read the Z table. Otherwise, we can move to the next section. If you want to explain, please send a message into chat box. I will explain it. Otherwise, I hope that you can do it. To say that explain, then how about others? I think T table is with you, no? I have shared the T table with you. Okay, I shared the T table again. Sorry, Z table with you. It is in the chat box. Okay, and then you want to find probability in this area. Okay. Then the first step is you have to convert these values into Z. Then when you convert 45 into Z, then it's become minus 1. This become plus 1. How to convert? Z is equal X minus X bar divided by standard. Then x is 45. Then the x bar is 55. Standard deviation is, we assume, 10. Okay, it is 10. Then answer is -1. Then here +1. Then to read the Z table, you should have two decimal places. 1.11 minus 1.00 plus 1.00. Then in this table, you have only positive values. Then you can see here 1 is here, 1.00. 1.00. The value is this 1.00 here. What is the value? 0.813. 0.813. Then in this table, actually, the probability is given, let's say here 1. It gives probability related to this highlighted area. That means if you take our example, it gives probability related to, let's say this area is, let's say A, this area, let's say B. Okay. Then here 0.81413 mean A plus B. A plus B is equal 0.8413. Is it clear?
Yes.
Then actually we want to find only the area related to B. Then how to find area related to B? Okay, then we want to find only area B. Then how to find area B? If I put here C, this area, okay, in this area A, what you can say about A and C? A and C. Yes, any idea? A and C?
They are equal.
Yes, they are equal. Why they are equal? This that means this distribution is a symmetrical distribution. No? This is a symmetrical distribution. Then here -1, here +1. Then these two regions are equal. Then, and also you know, A plus B plus C is equal to, if you take A plus B plus C, it is equal to, what is the value? A plus B plus C?
100%.
Yes, we can say 100% or we can say 1. It is equal to 1. Then you can easily find value for C. How to find value for C? You know the value for A and B. It is given here, this value. 0.8413. Then once you subtract this value from 1, you can get the answer for C. Then again you have to subtract that value from A plus B to get the value for B. Then it's become 0.68. Now it should be clear to you. If you have further any clarification, you can raise. Yes. Okay, then similarly, you can check quickly if the, okay, I will give some example. Let's say if Z value is -2, what is the probability here? Z is -3 to +3. What is the Z value? Please check. Please get the answer from table and send your answer into chat box. Now Z value is given. No need to convert it into Z. What is the probability that Z is greater than -2 and less than 2? Greater than -3 and less than 3. Please check the table and send your answer into chat box. I hope you can get the answer. Then you will have to read +2. What is the answer here? Same method you can apply. 0.9772. It is from this part. Then you have to find the value for right side tail and get the answer. One has sent the answer. Others also can check. Otherwise, at the end, you will be in a trouble. Please check whether you can figure out it. Okay, I hope you can do it. Okay, then we will move to the next concept. Now here I am going to explain how we can find x value for the given probability. Now we know z is equal x minus population mean divided by standard deviation. Now in this formula, you can solve for x. If you solve this equation for x, then you can put the cross multiplication. Then this one you can get to be side plus mu is equal to x. Then let's say if you are given standard deviation and mean and z value, you can find the value of x. Then to find the z value, sometimes they may give the probability. Let's say they can give x is greater than, probability x is greater than some value, they have given the probability. Then based on probability, you can find the z and you can find the x. We can move to one example. Let's say x represents the time it takes in seconds to download an image file from the internet. Let's say now we are downloading some files from the internet. Let's assume it is normally distributed with mean is 18 and standard deviation 5. Then they have given information x represent time it takes in second to download an image file. X such that 20% of download times are less than x. That means 20% of download time. That means this area should be 20%. Less than x. 20% of download times are less than x. X is the time. Then they asked to find the value for x. Value for x. What is the value x? How to find it? Then the probability is given. Then the first you can find the z value. What is the value for z here? If the probability is 0.200, what is the z value? Then if you know the z value, then you can use this formula. You can use this formula. If the z value is given, you can use this formula to find value of x. Try to do this example. How to find z value. Then from the table, now you have to search this value. They have taken table with minus values. If I go for the table I have given to you, then now you have to find actually this area should be 0.200. And you know this is similar to this part. Then if you read this one, it become minus. Here same value plus. Then from this table you can read and you can change the sign. Then the 2.00, what is the nearest value? Yes, now you want to find 2.00. But in this table actually how to find it? Is it given 0.200? In this table, they have given value related to this area. Then let's say we want to find it, this part should be 0.20. Then what could be this part? 0.800. Then if you search 8.00, 8.00, okay, 8 point, you can see the nearest value is here. Nearest value is 8.08. This value will be 8.8. This is plus. Then what is the value here? It should be minus 8.4. Did you get the point?
Yes, sir.
Okay. Then we will move to again our PowerPoint presentation. So, then they have used the different table. Some table they are given minus value also. If the minus value is given, then you can get the direct answer. Then the Z value is minus 0.84. Then you can insert given value here. Then the X is 13.8. That means 20% of download times are less than 13.8 seconds. Are less than 13.8 seconds. Okay, is it clear?
Sir, how did you decide the minus for the 0.84?
Yes, that is now they told that actually in the question find x such that 20% of download times are less than x. Then if you take this curve, this is 100%. Then the 20% of download times are less than 20% mean this part. Then this should be a 20%. And the mean value is given here. It is 18. Then we know that this area 50%. No, this is 50%. And this area also 50%. Then this whole area 50%. Then this should be minus 1 because it is less than mean. It is less than mean. Okay, shall I give you one more example similar to this? Let's say I can say 70% of download times are less than x. Then what is the value of x? Try to find it. 70% download times are less than x. What is the value of x? Then 70% may be somewhere here. Then this area should be now 70%. That means 0.777. Then find the value x and z here. Try to do this one. Send your answer into chat box. I'll give maybe 2-3 minutes. Please do the exercise.
Today, we are excited to introduce Divi Teams, a new foundation that
Hey, everybody.
Two answers. One is 20.6. Yes, most of them say 20.6. One say that 15.4. That is wrong. It should be 20.6. No. Then the probability is now 70%. Then what is the Z value? Yes, what is the Z value? Z value here? Yes. Come on. What is the
Point 2,
point?
5,
5, 2. Is it correct? 5, 2, there should be 0, 0. So, Z value is, yes, 5.2. 5.2. Then you can insert this into formula. Formula is this one. Z is equal 5.2 here. Five two. Z is equal 5.2. Then the standard deviation is given. Mean also given. Standard deviation value given 5, mean is 80. Then the x should be equal 18 plus 0.52 into standard deviation 5. Then the answer should be 20, 20.6, 20.6, 20.6. This is. Okay, then if I ask the same question in a different way, let's say find x at that 20% download times are more than x, then what is the answer? What is the value of x? If the 20% of download times are more than x, what is the value of x? Try to find the answer. Then now this area now should be 20%. Then what is the x and z? If this area is 20%, this part is 80%. Then again, you can search the 0.8, then you can find value here. Then using that z value, you can find the value for x. Okay, one say that 22.2. How about others? Please do that exercise also. Yes, most of them say that 22.2. Then you can check whether you can get the same answer. Okay, then we will move to another concept. Then here I am going to explain how to evaluate whether the data or variable is normally distributed or not. Okay, you should know whether it is actually normally distributed or not. All continuous distribution are not normal. Some are maybe left skewed, some are maybe right skewed. You should know how to identify whether distribution is normal or not. There are many criteria. Here I am going to few criteria that you can use. Normally distributed data should approximate theoretical normal distribution. That means theoretically these conditions should be satisfied. Normal distribution is bell-shaped where mean equal to median. Then the one criteria you can check whether mean and median is equal. If this condition is satisfied, it may be a bell-shaped distribution. Then the second criteria is empirical rule applied to the normal distribution. We learn empirical rule. The empirical rule says within one standard deviation from the mean, there are 68% observation. Within two standard deviation, there are nearly 95. Within three standard deviation, 99.7. Then you have to check whether this rule is applicable. Okay, whether this rule is applicable. How to check it? Now let's say your sample size is 200 as in our example. You can calculate mean and the standard deviation. Then you can check within one standard deviation. Let's say mean is 55. Standard deviation is 10. Within one standard deviation mean 45 to 65. Then your sample size is 200. There are 200 cases. Then you have to check in this sample how many observations are within this range. According to the empirical rule, how many observations should be within this range? Yes, any answer? How many observations should be within this range? Yes, how many observations? How many observations should be within this range? Yes, any answer? Yes, yes.
68.26% of the observations.
Oh, as a percentage, it is 68%. Now our sample size is 200. Then I'm asking how many observations? Then 130? 136 observation should be within this range. Then in your data set, you have to check how many observations are in this range. And We have to check whether it is 60% or something else. Okay. Let's say if there are only 48 observations in this range, then is it a normal distribution? No. It should be at least 130 or nearly 136 should be within this range. I hope you got the point. Then third is interquartile range of the normal distribution is 1.3 standard deviation. What do you mean by interquartile range? It is the difference between Q3 and Q1. Q3 and Q1. If the distribution is normal, let's say if the distribution is normal, the interquartile range should be 1.3 standard deviation. Okay. Now let's say interquartile range is let's say 30. Then this 30 should be equal to 1.3 into standard deviation if distribution is normally distributed. That means if the standard deviation, when you multiply by 1.33, it should be equal to interquartile range. Okay. Theoretically, you can check these three conditions: mean and median, and the empirical rule, and the interquartile range. Okay, then we will move to the another method. Then we can identify these three conditions with the chart or graphs. For a small or moderate size data set, we can construct stem and leaf display or block spot to check for the whether it is symmetric or not. Okay. And for the large data set, we can have a histogram or polygon, and whether we can check whether it is a bell shape. Then the descriptive summary measures. We can do the mean, median, mode. We can check whether mean, median, mode are similar. Is the interquartile range approximately 1.3 standard deviation? And also another one is the range is approximately within 6 standard deviation. Then another set of criteria is approximately 2/3 of observation lie within 1 standard deviation. That means 68%. Approximately 80% within 1.28. Approximately 90% observation lie within mean plus or minus standard deviation. Then we can evaluate the normal probability plot. Then the normal probability plot means we can arrange data into ordered array, then find the corresponding standardized normal quantities. Then we can plot the pairs of points with observed data value x on the vertical axis and the standardized normal value on z axis. Then I can show it with the example. Now, normal probability plot means first we arrange our data in ordered array, that means ascending order. Then we can find standardized normal values, z values. Then we can plot the pair of points, that means observed value x and the z value. If it is linear curve, okay, then it is a normal distribution. Then when you plot the x and z, if the curve is like this, the normal probability plot for the data from the normal distribution will be approximately linear. It is a linear curve like this. Okay. Approximately linear. Then if it is a left skewed, the normality curve is like this. If it is a right skewed, normal curve is like this. If it is a rectangular, the normal curve is like this. Then another example, let's say minimum is given, first quartile, median, third quartile, and maximum. Then you can evaluate whether distribution is normal or not. Then the box plot shows that it is a left skewed one. Tail is in the left side. Then we have another example here. Please check whether the return of 2008 is a normal distribution or not. Yes, whether it is normal distribution or not. Then the one condition you can check, mean and median. Mean is 1.317. Median is 2.6. If the normal distribution, mean should be equal to median. Then now here mean and median are different. Then what would be the shape of this distribution? Mean is less than to the median. Then it is not a normal distribution. But you can say the shape of the distribution. What would be the shape? Now mean is less than median. Yes. Then what is the shape of distribution? Whether it is left or right skewed. Yes, any answer? Mean is less than median. Then what is the shape? Yes, come on. Any answer? Yes,
Left skew.
it should be a left skewed one like this. Then the if the distribution is normally distributed, the interquartile range should be within 1.3. Now they say that it is interquartile range is 9.6. It is 1.25 standard deviation. Interquartile range, it is not given here, minimum maximum, it is not given. Let's say it is 9.6. Then why say that it is 1.25 standard deviation? The standard deviation is given here 7.653. Okay. Then if you divide 9.6 by the standard deviation, the answer is 1.25. That means interquartile range is 1.25 standard deviation. Standard deviation into 1.25. If it is normal distribution, it should be a 1.33. I hope you got the point. Then if the distribution is normal, the range should be within 6 standard deviation. Now here range, minimum range is given 46. Then the 46 is 6.13 standard deviation. That means if you divide 46 by standard deviation, 7.653, it is 6.13. But if it is normal, it should be within 6 standard deviation. Then 76.1 observation are within 1 standard deviation. That one actually, to check, we should have a data set. If we have a data set, you can check how many observations are within 1 standard deviation. Within 1 standard deviation mean 1.1317 into the standard deviation 7.653 and minus it. Then 88.3% observation within 1.28 standard deviation. Theoretically, it should be 80%. Like this, you should be able to check whether the distribution is normal or not by looking the given information. If you have any doubt, you can raise.
So can there be a situation where some show that it's normal and some contradict?
No, actually, yes, that's actually theoretically we have nearly mean, median should be equal. Then there are 3 sections. Then it should be applicable empirical rule. And also interquartile range should be within 1.3 standard deviation. Then let's say mean, median are equal, but empirical rule is not applicable. Then it is not normal. And interquartile range also not applicable. Then it is not a normal. But there may be some slight difference. We can't expect 100% normal distribution. We can say it is approximate to the normal distribution. In the mean, median also there may be slight difference. And the empirical rule also there may be slight difference. interquartile range also slight difference. But you can say then it is approximate to normal distribution. You can't expect 100% normal distribution. You can have a distribution approximate to the normal distribution. Okay, then I want to give assignment for you. Then actually I'm thinking your assignment based on stock market data. Then are there anyone who have access for daily stock market data? That means if you have an account, I think then you have access, otherwise you don't have access. Are there anyone with account to get the data from Colombo Stock Exchange? Because I don't have an account. Otherwise, I will have to create an account to get the data. It is better if someone has account, then we can get some data set and I can give you assignment covering all these measures we discuss. Maybe not. Let's say for one stock, if you can give let's say monthly data, that means the 30 observation. Let's say stock. If you take the stock A, then if you can give at least 30 observation for selected stocks, then we can do analysis. If we can have more than 30, that is good, but at least 30. Yes, please check and let me know, then I can give a assignment, then or else then it will be a very benefited for you that it is a practical one, then you can learn how to analyze stock market data.
Sir, I have an account and I can get the past data, sir. Even
Okay.
longer than
then that I need actually, let's say for the selected now in our class, I think here nearly 32, in the other batch of nearly I think 80 students. Then we can have a group work, then we can give, let's say 2 or 3 stocks data, firm data for each group, and we can ask them to analyze. I think if you can share with one the data set with you, then we can have a discussion and I can finalize it. Okay. Can you email me to sample data set related to one firm, maybe 1 month data or maybe 2 month or 3 month historical data?
Sure, sir. If you can tell me the stock you need, I can get it from you.
No, any stock you have, you send to me, then I can go through and we can have a discussion, because you may have some idea about the practical situation about the stock market. Then we can have a discussion and I can finalize your assignment. Okay. Maybe if you can send, maybe early next week, maybe Monday or Sunday, we can have a discussion with you. Then I can finalize it.
Sure, sir. I can download it and send it
Okay,
across.
okay. Okay, and also one more thing. Actually, today we had one field visit for Econ student, that means the Master of Economics student. I am teaching their statistics. Then I gave them to do a field survey. Then we can, for your group, for MFP also, we can do a field survey and we can collect data from the field and we can learn how to analyze it for your group. A second group, there are two group works or assignment we will have to do to get a practical experience. I can arrange a field visit, maybe do one survey in a selected topic related to finance. It may be microfinance or maybe saving or any other thing. Then that one also we will discuss maybe in the next week. That means if you wish, we can, now they actually do the survey in Colombo area near to the Colombo University. There is one GN division, I think, Samagiwatta, near to Asiri Hospital. They are doing the survey there. Like this, we also can do a field survey in selected location, and we can collect the data and we can enter data into computer software and we can analyze it. Okay, you can think it, then the next week we can have a discussion and we can finalize it also. It may be good to you because it may increase the interaction between your group members. Now actually only one day you are visiting per 1 month you are coming to the university for 1 day. You can use maybe last that means that our on-site class day for the field visit. We can collect the data and do a small study. What is your idea? Are there any idea about that? Do you like to do a field survey? Yes. Okay, one say yes. Okay, then later we can decide it. Just this is idea. Then we will meet next week, and I'm going to